Climate is the prevailing long-term weather conditions found in an area affected by factors such as sunlight, moisture, seasonality, mountains, and oceans. Species are adapted to the abiotic conditions present where they live. An array of abiotic factors affect organisms, including the chemistry of water in aquatic habitats, the nature of soils in terrestrial habitats, and climate, which is the prevailing long-term weather conditions found in an area. Weather consists of the specific short-term atmospheric conditions of temperature, precipitation, sunlight, and wind. Although meteorologists might not always make good predictions, climate occurs in relatively predictable global patterns. When average annual rainfall is mapped for regions around the globe, it's clear that areas along the equator receive the most moisture. Locations at 30 degrees latitude north and south of the equator are among the driest on the planet. A global air circulation cycle called the Hadley cell is responsible for making the Amazon River basin wet and the Sahara Desert dry. Hadley cells are named after George Hadley, who conceived of the idea of enormous air circulation patterns. Air that is heated by the strong sunlight along the equator expands, lowering its pressure and causing it to rise. Warm air holds more moisture because warm air molecules tend to stay in vapor form instead of condensing into droplets. As air rises above the equator, it radiates heat into space. It also expands into the larger volume of the upper atmosphere, which lowers its density and temperature. As rising air cools, its ability to hold water declines. When water vapor cools, water condenses, and the results, high levels of precipitation occur along the equator. As more air is heated along the equator, the cooler, older air above Earth's surface is pushed poleward. When the air mass is cooled enough, its density increases and it begins to sink. As it sinks, it absorbs more and more solar radiation reflected from Earth's surface and begins to warm while being pushed to the surface by higher density air above it. As the air warms, it also gains water holding capacity. So the air approaching the Earth holds onto its water, and little rain occurs where it returns to the surface. The result is a band of deserts in the vicinity of 30 degrees latitude north and south. These areas are bathed in warm, dry air. Similar air circulation cells occur between 30 latitude and 60 latitude as well, and also between 60 degrees latitude and the poles, both north and south. In general, areas of the world are warm if they receive a large amount of sunlight per unit area. They are cold if they receive a small amount of sunlight per unit area. Over the course of a year, regions at or near the equator receive much more sunlight per unit area, getting more energy in the form of heat than regions that are closer to the poles. And at the equator, the sun is often directly overhead. So as a result, sunlight strikes the surface at or close to an angle of 90 degrees. At these angles, Earth receives a maximum amount of solar radiation per unit area. Earth's surface slopes away from the equator, so sunlight strikes the surface at lower angles as you move towards the poles. When sunlight arrives at a low angle, much less energy is received per unit area. The pattern of decreasing average temperature with increasing latitude is a result of Earth's spherical shape. The striking global patterns in temperature and moisture are complicated by the phenomena of seasons. Seasons are defined as regular annual fluctuations in temperature, precipitation, or both. Seasonality occurs because Earth is tilted on its axis by 23.5 degrees. In December, the southern hemisphere presents its least acute angle to the sun and receives the largest amount of solar radiation per unit area. In other words, the southern hemisphere is tilted toward the sun in December. In this position, it faces the sun most directly. The wider the angle presented toward the sun, the more solar radiation per unit area a region will receive. In June, the northern hemisphere is tilted toward the sun, so it faces the sun most directly and receives the largest amount of solar radiation per unit area. In June, it is summer in the northern hemisphere and winter in the southern hemisphere. Conversely, in December, it is summer in the southern hemisphere and winter in the northern hemisphere. In March and September, the equator faces the sun most directly. During these months, the tropics receive the most solar radiation. If Earth did not tilt on its axis, there would be no seasons. Broad patterns of climate that are dictated by global heating patterns, Hadley cells, and seasonality are modified by regional effects. The presence of mountain ranges tends to produce extremes in precipitation. The most important of these are due to the presence of mountain ranges and proximity to an ocean. In this area of the world, prevailing winds are from the west, bringing moisture-laden air from the Pacific Ocean onto the continent. As the air masses begin to rise over the mountains, the air cools and releases large volumes of water as rain. Once cooled, air has passed the crest of a mountain range. The air is relatively dry because much of its moisture content has already been released. Areas that receive this dry air are said to be in a rain shadow. One of the few high-latitude deserts in the world exists to the east of the Cascade Mountains. It's created by a rain shadow and averages less than 25 centimeters of moisture annually. The presence of an ocean has moderating influence on temperature. Water has an extremely high specific heat, meaning that it has large heat capacity, the capacity for storing heat energy. Because water molecules form hydrogen bonds with each other, it takes a great deal of heat energy to boil water or melt ice. The hydrogen bonds have to be broken before the water molecules themselves can begin to absorb heat and move faster, which we measure as increased temperature. Because water has a high specific heat, it can absorb a great deal of heat from the atmosphere in summer, when the water temperature is cooler than the air temperature as well. So as a result, the ocean moderates summer temperatures on nearby land masses. The ocean releases heat to the atmosphere in winter when the water temperature is warmer than the air temperature. Due to heat capacity of water, then, coastal areas have more moderate climates than do inland areas.